In fact, in mobile IP, these are the topics that we are going to cover. We are going to look at what is mobile IP, what is the context in which mobile IP comes into picture. Then what are the requirements? What are actually the requirements are the reasons for having mobile IP? Okay. Because we already have fixed IP. Already we know fixed IP network addresses, how IPv4 and IPv6 addresses are allocated, all that you know. So that is the prerequisite, right? And then we look at what is the architecture and the working of mobile IP. After that we look at the core of the chapter, which is packet handling and handover management. Okay? Handover management. What happens when one mobile station moves from one network to another network? It has to transfer all its services to the other network. That is handover. Okay? So that we study, and then we look at also location management. Okay? So handover management and location management are very closely related. Okay? How do we locate where to transfer the services? How do we locate the foreign agent? How to transfer, and all that comes into location management. Again, in location management we have agent discovery and registration. Within agent discovery we have two methods, which are agent advertisements and agent solicitation. Okay? So they are the methods in agent discovery process. Then we look at concepts of tunneling and encapsulation. Okay? Then we look at various types of encapsulation. Then we look at what is the need for reverse tunneling, why we require reverse tunneling. Then we look at TCP, mobile TCP, how it differs from normal TCP, and some methods which are indirect TCP and your mobile TCP, and then snooping TCP also. Okay. And then also we look at another mechanism in mobile TCP, which is called fast retransmit and recovery mechanism in mobile TCP. So first, looking at what mobile IP is, this diagram will best illustrate what happens when a mobile station moves from one network to another network. You can see the animation. Here you can see the mobile station in a home network moving to a foreign network. There is a mobile station in the home network, it has moved to a foreign network. Now you can see there are two addresses here, one is the home address and the other is the care of address. You can see that the home address for this node remains the same as in the home network. In the home network, its address is 131.5.24.8. The same address is present even in the foreign network. But you can see there is additionally something called the care of address. Okay, here you can see it is 14.13.16.9. So that address will change every time when the mobile node visits a different foreign network. Every time it visits a different foreign network, that address will keep changing. So there are two addresses. We will come back to what these addresses are later. But again, you can also see there are some things called home agent and foreign agent. Okay? A home network has home agent and a foreign network has foreign agent. So mobile nodes can never directly communicate with each other. They have to do using the agent. It is like a ticket booking agent who will take care of all the customers. Okay? So a foreign agent, a home agent will do the job for the home network, and a foreign agent will do the job for the foreign network. So a home agent can communicate with a foreign agent, or a foreign agent communicates with the home agent. But directly, two mobile nodes cannot communicate with each other. And you can see, when we introduce mobile IP, first we need to see the context, the context in which mobile IP comes into picture. Okay. Though we have static, not static, but the fixed IP addressing, the current versions of IP assume that every node is attached to some point in a network. And it is identified by something called the IP address. Okay. And as long as the node is within that network, its address is same. Its address is fixed. However, when a node moves to a different network, when node moves to some other network, okay, its IP address cannot be the same, because that address must correspond to that network's address. Okay. You know, the first 3 octets will determine the network's address, say. Only the last octet will determine the node number. So every time when a mobile node, when a node moves to a different network, its address, should we change its address or not, is the point here. Okay. One thing is, one option is to change the address. Every time when a node goes to a foreign network from the current network, okay, because mobile nodes are always moving, constantly they are moving. So, should we change the address, is one option. Okay. But what happens if you change the address every time? Every time the address changes, okay, the connection is lost, because everything have to be reset. The routing table, the mechanisms and the port numbers and everything have to be reset. We will see what are the problems. On the other hand, if you don't change the address, then the new location will not be identified. So if we change the address, we lose the connection. If we don't change the address, we lose routing. Okay, the concept of routing itself is lost. So what is the solution to this problem? So now you can see what the solution to this problem is. Okay. In fact, mobile IP offers two solutions to this problem, right? So one solution is to use two addresses. One address corresponds to the home address, which will always remain the same. You have seen in the earlier diagram. The home address remains the same even when the node goes to another foreign network. Okay. But another network, another address called the care of address will be changing from one foreign network to another foreign network. Because I have one home network, there can be many foreign networks. Okay. When my mobile node moves to one foreign network, it will have one care of address. If it goes to another foreign network, it can have another care of address. So care of address is variable, while the home address is fixed. So what is the advantage of this? Okay, the advantage of doing this is computing activities are not disrupted. Whenever a node moves to a new network, okay, we can ensure that the computing activities are not disrupted. We cannot say they are not completely disrupted, but there will be lesser disruption. Okay. Whenever one mobile node changes, moves to a new network, there will be an intermittent disconnection, small disconnection. But using this mechanism, we can reduce the time of disconnection. Okay, that is called handover. Okay, that's also called handover. We can reduce it such that the user cannot even observe it. Okay. On the other hand, if you change the IP address, if you give a new IP address, then that will be a lot. There will be a lot of disconnection time. Okay. So which makes it completely disconnected, because you have to again reconnect very fast. Very fast you have to reconnect even if there is a disconnection. So this will allow that. Okay. We cannot say there is 100% okay, it's 100% free of disconnection, but the time will be reduced using this mechanism. Right? In fact, you can see every mobile node we said will be given a care of address. The care of address corresponds to the foreign agent's address. We have seen in the earlier diagram. A foreign agent is also a node. It is also a system. Right. So it also has some IP address. IP address. So the IP address corresponds to the IP address of the foreign node. So all nodes that move from the home network to the foreign network will be given the same care of address as that of the foreign agent. Okay. So this is one option. I told you there are two addresses. Okay. The first option is every node has the same home address. Okay. Whenever a node moves to another foreign network, its home address will remain the same, but the care of address change. The care of address is the address of the foreign agent. Care of address is nothing but the address of the foreign agent. Okay. So this is one scenario where you will have two addresses, one fixed address and one variable address. The other way is to assign a node a separate address. DHCP, dynamic host control protocol. So it dynamically assigns IP addresses. Okay. So actually, when do you require this type of address? When the foreign agent is not present, okay, or the foreign agent is present, but its functionality. Who has to give the addresses? The home agent itself has to give the address. Okay. So itself has to give addresses using DHCP. Then foreign agent will not come into picture. Okay. That is another way. Which method do you prefer? The first method or the second method? Obviously, the first method is preferable. The reason is you are giving only one. What is that address? The care of address. Care of address of the foreign agent. You are able to give only. You are able to do with giving only one address to a group of nodes in the foreign network. Okay. On the other hand, with the second option, every node you must give a separate address. So we will see what are the disadvantages of doing this, giving a separate address to every node, right? Obviously, the first choice is better because the address range is limited. Whether it is IPv4 or IPv6, we have limited address range. Okay, and if we give too many new addresses to nodes, then ultimately the address space will be exhausted. We'll lose complete address space. Because you know IP addresses have to be given to all devices, not only computers but also other handheld devices and other things. So we have to limit the number of IP addresses. Right? So obviously we discussed about what is the care of address, but then we have another thing called co-located care of address. Okay. The co-located care of address is nothing but the address that is given by the home agent itself. I told you, using DHCP. So it will terminate the tunnel. It will terminate the tunnel, and it doesn't require to enter the foreign agent end. It will look at it as a tunnel between a home agent and a foreign agent. That tunnel will be terminated at the home agent itself, at the home network itself. And you can see this is different from the care of address, where first a mobile that's there in a foreign network has to contact the foreign agent. Okay, then the foreign agent again has to contact the home agent. Okay, we'll see all this registration process later. So co-located care of address allows a mobile device to roam to foreign networks where foreign agents are not deployed, or foreign agents are present but their functionality is not present. Okay, the foreign agent is there, not as a foreign agent. In that case, there is no point of sending there. Okay, the home agent here itself assigns the address. Now actually we come to see what is mobile IP, what is its architecture, after seeing why it is needed. We can see mobile IP is defined by, it was defined by IETF. And it is a standard that allows mobility of nodes. That allows nodes to move from one network to another network without having to change their address. Their original address is preserved, but it is hidden under some other address for the purpose of security. Okay? At the other end, the original address can be retrieved. We will see how it happens later. So now we actually see what are the requirements for mobile IP. Why do we require mobile IP? One thing is, if you use the existing IP, that is node a separate address, okay, then it will lead to exhaustion of your address space. Okay, you know, even IPv6 allows a few millions of devices or billions. Is it millions or billions? Okay, that number is likely to cross with so many devices. Even IPv6 is likely to be exhausted. So giving a separate address to each of mobile nodes is not a good option. The next reason is need for upgrading the capacity of the data link devices and other. For example, we can see all current devices at the MAC layer have 48-bit addresses. 48-bit addresses. So if obviously the size of the IP increases, the IP size increases, then we also have to define new protocols and okay, at the MAC layer we also have to increase the address size of the MAC addresses. Okay. Similarly, at the physical layer we have to define new standards for transmission, right? So all these are effects of the if you give too many IP addresses, then the address space, IP address space will not be sufficient. If you change IP, then all other layers also have to be changed. Okay. Coming to the third point, which is the security need. Okay. Whenever a mobile node moves from one network to another network, okay, the original network must not be able to track the mobile node, where it is moving. Okay. Otherwise, if the original network is able to continuously see where that node is moving, there are greater chances of attack. Okay. The sending network must not be able to see. Only the other network must be able to see. The other network must, within that network it is visible. But for the sending network it must not be visible, completely visible. Otherwise there are more chances of attack. Okay. That is why that address is hidden within this address. We will see and send. That is encapsulation, right? And we see the next point is need for transparency from higher layers. Okay. Right? Because network layer and transport layer are very closely tied to each other. Network layer has IP addresses, transport layer has port number. So every time IP address is changed, we have to change the port numbers also. And if we change the IP addresses and the port numbers, it will result in disconnection. Okay. So there needs to be transparency from the higher layer. When higher layers see, they must be able to see the same address. They must not see a different. So they can still use the same port number and other things. Able to follow? Another reason is re-establishment problem. Okay. Let us say an IP address is completely changed. Okay. Then the port numbers and other things are also to be changed. Then complete disconnection occurs. Okay. On the other hand, even if a mobile node changes the network, it must be able to quickly reconnect, even if there is a temporary disconnection, because you have to allocate the care of address and other things. So obviously there will be a small disconnection. So care of address is assigned at the foreign network, then that has to intimate, get back and register with the home network. All this will take some time, but the time must be very, very small, so that disconnection does not take place. Okay. Finally, the need to update routing tables. Every node has some source address where it is coming from and the destination address where the packets have to go are in routing table. So if you simply change the existing address, then you have to change all the routing tables. Okay. Every time you give a mobile node a new address, you have to change all the corresponding entities, which will be a huge load on the network. Updating routing tables is very costly. Okay? So it is not a feasible solution. So why we are seeing all this is, we are looking at why we cannot give an new IP. Okay. Current mobile node has one address, IP address. Why can't we give it a new IP address when every time when it goes to a new network, a foreign network from a home network? Okay. We can try to limit. It doesn't mean we are not giving any address at all, but we are limiting the addresses that are given to the node by using this COA and other concepts. Right? We will see exactly how it is done later. Looking at the architecture of mobile IP, we have seen that we have a home agent in mobile IP. We have a home agent which is present in the home network, which takes care of mobile nodes within the home network. Okay. So any correspondence in the home network will be taken care of by a home agent. Similarly, we have a foreign agent which takes care of the visiting nodes. Okay, the temporary nodes that are visiting the network can only communicate with another network using a foreign agent. Okay. So obviously I told you there can be communication between a home agent and a foreign agent, and a foreign agent and another foreign agent also. Okay. From one foreign network to another foreign network, between two foreign agents there can be communication, but two mobile nodes cannot directly communicate with each other. The next thing we have seen is the same software can act as both home agent or a foreign agent. Okay. Within its network it can act as home agent, but for some nodes coming from other networks it can function as a foreign agent. Now we have seen what are all the components present in mobile IP. We have seen that we have some mobile stations in the home network as well as in the foreign network. Then we have seen there is home network mobile switching center and foreign network mobile switching center. These are nothing but the MSCs, what we call MSC, and they are responsible for the handover from one network to another network is carried on by the MSCs. Then you can also see the home agent in the home network and the foreign agent in the foreign network, and you can also see some routers in the home network and the foreign network. Okay. And we have seen that a set of these MSCs together will form a paging area. So all this comes into one paging area. We have also seen that the home agent and foreign agent play similar roles to that of HLR and VLR in our GSM network. Okay. Where HLR was keeping track of the home location nodes, mobile nodes, whereas VLR was taking care of visiting nodes. Okay. So exactly these perform the same function. They have to maintain the details. And we have seen what a paging area is. Okay. Paging area includes all this, these switching centers and the mobile nodes present within them. Right? And routing happens from routing happens whenever a mobile node moves within the paging area from one network to another network. That is from one switching center to another switching center. And we have seen that switching center has a home agent which provides registration, okay, and similarly whenever a node goes to a foreign network, then it has to register itself with the foreign agent, and the foreign agent again has to request the home agent. All this registration is taken care of, okay, through the switching center. And we have seen that the purpose of a home agent include transmitting and receiving packets to and from the internet, okay, and in addition assigning routers in the home network to different nodes, mobile nodes. Is to provide IP addresses, okay, to the visiting mobile nodes. That is nothing but the co-located addresses. Okay. Apart from that, it also does what is done by a home agent. Okay. That is sending and receiving packets from the internet and assigning routers. And these routers must correspond to the routers in the home network. So routers in the home network will communicate with routers in the foreign network. So the home network routers are assigned by the home agent and the foreign network routers are assigned by the foreign agent. And we have also seen in the diagram something called a corresponding node. Okay. And we see that a corresponding node is any node that is sending or receiving at that particular instant of time, at that particular point of time. And the corresponding node could be either fixed node or it can be a mobile node. The corresponding node could be either fixed or mobile node. And it can be present either in the home network or in the foreign network. And then again we have also seen that whenever a mobile node moves from a home network to a foreign network, there is something called handover that occurs. Okay. And handover management involves in how to transfer the service without much disturbance from this network to the other network. Seamless transfer of services from the home network to the foreign network, okay, is called handover management. Okay. And location management involves in where we want to transfer to, what is the location of the foreign agent or what is the foreign agent to which we have to transfer is the purpose of your location management. Okay. So handover management is how to transfer a service, while location management is where to transfer a service. And again you can see another another diagram, another version of the same diagram where you also have a corresponding node additionally. Okay. And you have a foreign agent and home agent in the home network. Okay. And in the foreign network we have the foreign agent. And you can see there is something interesting, that is a tunnel between the home agent in the home network and the foreign agent in the foreign network. It is a tunnel. And actually it is through the tunnel that we send packets, encapsulate the packets and send, which we will see later. Again, then we have seen different scenarios. Okay, we have said a corresponding node can be fixed or mobile. Okay, and it can be present in the home network or in the foreign network. Okay. So whenever transfer of data has to happen between networks, always there is a source and there is a destination. So there are different scenarios where corresponding node can be fixed node, and in the home network destination is a mobile node. Okay. Again, other scenarios where the corresponding node is a mobile node in the home network, okay, and the destination node is mobile, and it might again be present in the home network or in a foreign network. Okay. All this leads to different scenarios, 6 scenarios. Okay. So looking at the first scenario, where we assume a fixed corresponding node is fixed, it is present in the home network, and the mobile node is also in the home network. Of course, I told you mobile node cannot be fixed. Mobile node is always mobile. Only thing is it can be present in the home network or in a foreign network. Okay. So in the first case we are assuming fixed both the corresponding node and the mobile node in the home network, and the corresponding node is fixed. This is the simplest of scenarios. Okay. And you can see how it is done. You can see that the corresponding node first sends the data through the router, through the home agent, and to the mobile node. Okay. So CN to HA1 and HA1 to MN1. On the way back, MN1 sends to HA1 and HA1 again sends to CN1. That's how the source and destination communicate with each other. Remember, this is the simplest of scenarios. In the second case, again both corresponding node and mobile node are in the home network, but this time the corresponding node is mobile, it is not fixed. Corresponding node is mobile and in the home network. Okay. And the mobile node is also in the home network. Then we can see the sequence. Here the corresponding node MNK would first transfer to HAK, HAK transfers to HA1 and HA1 transfers to MN1. On the way back, MN1 transfers to HA1, HA1 to HAK, and obviously HAK to MNK. So this is also a relatively simple scenario. Okay? A relatively simple scenario, where you have 2 home agents instead of 1 home agent in the earlier scenario. You can see there are 2 home agents here. You don't require a foreign agent. Observe that we have nothing to do with a foreign network, so we don't require a foreign agent here. Now coming to the third scenario. So in case 3, CN is a mobile node and is in the home network, while MN1 is in a foreign network. MN1 is in a foreign network. So you can see on the forward path, MNK sends to FAK dash, then FAK dash sends to HA1, HA1 sends to FAJ, and FAJ sends to MN1. On the way back, MN1 sends to FAJ, FAJ sends to HAK, HAK sends to FAK dash, and FAK dash sends back to MNK. MNK or the CN. So remember, the path between the home agent and the foreign agent is a tunnel, and it is used for encrypting and sending the packets for the purpose of security. So we have four addresses. Two of the addresses are addresses of the home agent, and the care of address. Care of address is the address of the foreign agent, while the other two addresses are addresses of the corresponding node and the address of the mobile node respectively. Okay. So whenever a home agent wants to send packet to a foreign agent, it hides the corresponding node address and the mobile node address, IP address, within the home agent address and the care of address. Okay. Within its own address and the care of address. So whenever home agent needs to send packets to a foreign agent, it can only see the care of address of the foreign agent after the foreign agent registers with it. Okay. So how does it again know? You might ask me, how will it know the care of address? Every time the foreign agent has to tell that it's currently my care of address. Then the home agent will only send to care of address, and the foreign agent will take care of sending to the respective mobile node after removing the outer header, okay, which consists of home agent address, then the care of address, then the corresponding node address, then it obtains the actual mobile node's address, and it can send the data to the respective mobile node. In fact, we can compare this process with a post office analogy. A post office. Okay. Let's say you reside in a region. You are registered with that post office. You have some post box number. Okay. So any letters you get come to your post office. You are registered there. Okay. Now let us say you shift your location. You shift to some other place. Then what do you need to do? You need to register with a new post office. Okay. You need to again change your address, post box number to the new post office. Is it enough? Is it sufficient for your old letters to reach you? Yeah. Again, that new post office must contact the old post office and tell them that the address is changed and you have to route these letters to the new address. Okay. Only then the communication completes. So here in this scenario you can see the old post office is your home agent and your new post office is your foreign agent. Okay. So a mobile node needs to communicate with your once there is a change in address, then the mobile node needs to inform the new post office. Okay. Then the new post office needs to inform the old post office to send the letters there. Only then the letters reach you. Okay. This is the analogy. This is the analogy where a mobile node has to register with send a request, registration request to a foreign agent. Foreign agent will forward that request to the home agent, and home agent then gives a response, registration response to the foreign agent. Okay. And again the foreign agent sends back the response to the mobile node, Okay. See, the process is mobile node to foreign agent to home agent, back from home agent to foreign agent to the mobile node. After this entire registration process is complete, then the communication is established. Then the mobile node can receive all the services from the new network. Only then the communication is complete. Right. So this is case 3, and case 4 is obviously slightly more complex. where Cn is, in fact, in case 4, it's like Cn is MNK, Cn is mobile and is in a foreign network, and Mn1 and is in a foreign network with FAK, foreign agent FAK. Cn is MNK, Cn is mobile, MNK, same as MNK, and it is in a foreign network with foreign agent FAK. And Mn1 is in home network with agent HA1. Mn1 is in the home network with agent HA1. So with some experience you must be able to draw the diagram without seeing. Now you can see Cn is nothing but MNK, right? Can you see it here? And it is in the foreign network. And its agent is FAK. Agreed? While Mn1 is in the home network, here you can see Mn1, right? And its agent is HA1. Agree? Fine? Now we will see how packets are routed. You can see again from the home network to the foreign network. Okay. How do they pass? From Mn1 to HA1, HA1 to FAK, FAK and FAK to MNK, by encapsulation. Okay. And on the reverse path, they come back from MNK to FAK, FAK to HA1 and HA1 to Mn1. Okay. But remember, this encapsulation is to be, if we take the previous scenario, this encapsulation and everything has to be done only on the sending end, only from the source to destination. On the reverse path from destination to source, actually packets are sent directly without any encapsulation. Okay, right? So this encapsulation is one way, right? And this tunneling is one way. Tunneling is done only in forward direction. Reverse direction, packets are normally sent as they are. But again, there is a disadvantage of this method. Okay? And we can use reverse tunneling, a process called reverse tunneling, where we can also do the tunneling from the foreign agent to the home agent. Now we are only tunneling from the home agent to the foreign agent. In reverse tunneling, we can also do it from foreign agent to the home agent. Okay? What are the disadvantages of not using reverse tunneling? Why we will be required to use reverse tunneling? This is what we will see later again. Okay? There is a separate topic. In fact, you can see the path. Okay. What we have represented as FAK in the diagram, we are calling it FAK dash here. FAK dash. Clear? So this is case 5, where Cn is mobile and at the home network, and Mn1 is in a foreign network. Mn1 is in a foreign network. You can see MNK to, yeah. In fact, some of the steps might be missing here in the description, but here you can see FAJ to HA1, only this point onwards he might have described. Okay, but actually this is the complete path. from MNK to HAK, HAK to CN, to FAJ and to MN1. On the way back, MN1 to FAJ, FAJ to HA1, HA1 to CN and back to MNK. Okay. So this is the scenario in which CN and MNK are in a home network and your MN1 mobile node is in a foreign network. Okay. For discovering the agents. Okay. So after location management, then your handover management takes place. We can say, okay, once location management is done, then handover management takes place. So in fact, any mobile node can use two methods for discovering a foreign agent in a new network. Okay. In the first method, foreign agents periodically advertise themselves that I am present here, I am present here, does anyone want my service? Okay. So the foreign agent periodically sends advertisement, it advertises itself. That is the first method. So whenever a node enters a foreign network, if it sees an advertisement, then it can immediately correspond with that, with the particular agent. Okay. It can set up communication. On the other hand, if it doesn't find any foreign agent, okay, then it has to request. It has to say, ask, is any foreign agent is present, using solicitation. That method is called agent solicitation. Okay. So it requires, it checks for the presence of any agent. If the agents themselves are readily present, as can be found by their advertisement, then immediately we can it can directly correspond with that particular agent. Okay. For discovering the agents. Okay. So after location management, then your handover management takes place. We can say, okay, once location management is done, then handover management takes place. So in fact, any mobile node can use two methods for discovering a foreign agent in a new network. Okay. In the first method, foreign agents periodically advertise themselves that I am present here, I am present here, does anyone want my service? Okay. So the foreign agent periodically sends advertisement. It advertises itself. That is the first method. So whenever a node enters a foreign network, if it sees an advertisement, then it can immediately correspond with that, with the particular agent. Okay. It can set up communication. On the other hand, if it doesn't find any foreign agent, okay, then it has to request. It has to say, ask, is any foreign agent is present, using solicitation. That method is called agent solicitation. Okay. So it requires, it checks for the presence of any agent. If the agents themselves are readily present, as can be found by their advertisement, then immediately we can it can directly correspond with that particular agent. And you can see the process where the mobile node has moved to a foreign network, and then you can see the foreign agent advertisement in the form of ICMP messages. Remember again, the foreign agent advertisements are in the form of ICMP messages. They are similar to ICMP messages. Right. Then again, we check whether they are offering a new care of address or it's already the address that is existing. So there are three cases. One thing is whether it is the same care of address, same old address that is being advertised, or whether it is a new address that is advertised. Third case is it is the address of the home agent itself. It is the co-located care of address. So 3 cases. So if we see that it is a new COA, then the mobile node will register with that new COA. Okay, which will again be forwarded to the home agent, because the home agent has to be updated of the location. So process is, whenever a mobile node moves to a foreign network, when it finds a foreign agent, it should inform the home agent that it has found a foreign agent. So the registration process is two-way, right? And you can see agent discovery and registration involves the following steps: listening to an advertisement, listening to ICMP packets, okay? And if advertisements are found, then we proceed to step 3 and check whether the COA is already existing COA or a new COA. That means same foreign agent or a new foreign agent. That indicates whether the mobile node has changed the network or not, right? If it is a new COA, it means it has changed the network, right? If it is a new COA, or that the foreign agent might also have changed, because remember, foreign agents are also mobile. Foreign agents are also not fixed nodes. So for some time I will take the service of one foreign agent, but again that foreign agent may hand over to another foreign agent. That foreign agent will move away from my location. It will go to some other location. So that responsibility has to be taken care of by another foreign agent. Okay. So a new COA might indicate that that foreign agent has moved away. That service is not available. So I have to again register. Okay. Right? So if we discuss, if we discover as the same as previous COA, again still we detect for new COAs. Again, the other case is, I told you, if the COA is same as the home address, okay, home agent COA, then we have to deregister at this network, okay, and go back to the step 1. Okay, that means we are no longer using a foreign agent. Home agent, we are under the service of home agent only. So we deregister with the COA and go back to step 1. Okay, only 3 cases: whether the same COA or a new COA or the COA of the home address, home network. That is the co-located COA. If it is co-located COA, then deregister at this network and again go back and start waiting for advertisement, for a new COA. In any case, we have to wait for a new COA, that's all. As simple as that. Right? So these are the steps in the agent discovery process. And here we will stop after this. Okay. And you can see we have 2 cases. One case is registration in case of co-located COA. Other is in case of COA, foreign agent COA, different network. Okay. In the first case, it is enough that the mobile node registers with the home agent and home agent sends a reply back to the mobile node. In the second case, mobile node sends to foreign agent. I told you, whenever it enters a new network, it has to first send a registration request to the foreign agent, and again that will send the registration request to the home agent. In turn, the home agent will send a registration reply to the foreign agent, then to the mobile node. Then the registration process is complete. Then the communication is set up between the home agent and the foreign agent. Only then the communication starts between the mobile agent and the foreign agent. If any of these steps fails, then obviously there will be no communication between the home agent home agent and the foreign agent. Okay. In case of co-located COA, you can see there it is not required. If at all, if it finds the same thing, then it needs to deregister here the foreign network and it has to go back to the home network. Then it will only be sending to the home agent. Okay. Then it can only send to the home agent, and home agent will send back to the mobile node. Okay. There will only be communication between mobile node and the home agent if it is co-located COA, care of address. Okay. And when do we require registration? Sometimes even if it is co-located care of address, we require registration. That is the first time it is registering. When it is first time it is registering, it has to register even if it is CCOA. That is indicated by something called R bit, registration bit, in the advertisement packets. We will see the format of advertisement packets later. In that, if R bit is set to 1, it indicates it has to register. It has to register. It is a new registration. Even if it is co-located COA, even if it is the home agent, it has to register. On the other hand, there are other bits saying B, busy bit, indicates it will not accept any registration. It is busy to accept any registration, the agent. Okay. So that we will understand when we look at the packet format of the advertisement packet format, which we will see subsequently.